Visualization is often the grand finale of data analysis. In this Python for Finance free course, we've already covered quite a bit how to use, create, and analyze data. And we're going to carry on doing these things, but today we are indeed focusing on visualization and what is known as reporting. We're talking about making meaningful plots and charts with our data, whether you would like to use them in a report, a presentation, or an email, etc. Basically, it's about squeezing every bit of value from your data analysis. We'll be using another very popular Python library, Matplotlib. And we'll also take a peek at Seaborn. Now, don't forget that a written version of this course is available on our website. Anyways, let's get going.
Let's create a notebook for this chapter. So we'll call it chapter 6.ipynb. Press enter. Great. Now what we should do is to install Matplotlib if you haven't done that already. So in the new terminal, we'll type pip install matplotlib and press enter. I already have it installed, so you see there's no need for me to install it. But if you need to do that, that's how you do it. And remember pip, or sometimes you'll have to use pip3 if pip didn't work. Anyway, so now that we have Matplotlib installed, we have to import it in our code so we can use it within our code. So we'll do import matplotlib.pyplot, and we'll give it a nice little alias. So let's do as PLT. This is the common one generally used worldwide. Great. So we can just run this, and great. We're all good. We can now use it. So let's start with a basic example. I'll close the terminal so it's out of our way, and we'll create a new cell. So let's say that we're going to plot a straight curve, so a linear curve. So I'll just create a first list that where I'm gonna put 1, 2, 3, 4, 5, so 5 points. As you might have guessed, the reason why I'm calling this X is because this is gonna be my X-axis. In other words, my abscissa. And then we'll create our y-axis, so the list for the y-axis. So therefore, what we also call the ordinate. So let's now say that we'll do 5, 10, 15, 20, 25. Let's do that. So now this is the coordinates of the points that we're going to plot, right? So we have a first point that is at the coordinate 1, 5, a second point that is at the coordinate 2, 10, 315, 420, 525. Great. So that's the information that we want to plot. So now how do we use Matplotlib to do the plot? Where we'll use a method called plot. And then here we have to always give first the x-axis and then the y-axis. And then we want to display that plot. So we use the command, the method, beg your pardon, called show. So let's run this and see what we get out of this. And yeah, perfect. We have this straight curve, so a linear line. And as you can see, we don't see the points. Actually, when you do plot like this, just like this, it actually links all the points with a line. So if let's say we break our linear relationship so we can make this more obvious. Here I'll put 20, and then I don't know, we could go like, let's go to 50, then back to whatever. And you'll see that now, indeed, you can see that 1 point was here, 1 point is here, 1 point is here, 1 point is here, and I forgot the first one, which is here. And now you clearly see that there is a straight line that connects all those points. You can also see that the axes tell us indeed where the points are. We could check if things match well. For example, let's take this second point. So we have it at a abscissa of 2 and an ordinate of 20. That second point is indeed 220, so it's all good. And the others match as well, because that's indeed what we asked for. Anyway, this plot is very incomplete, because a plot without a legend is not a good plot. So we should always at least label the abscissa, that's the strict minimum, and then a title, why not? And also maybe later, if you have several curves on the same plot, you should also put a legend somewhere telling what each curves represent. But let's start with labeling the axis and giving a title to this plot. So here we'll come and add a little PLT method as well. And actually Matplotlib is quite intuitive. So if you want to add a label to the x-axis, you simply go plt.xLabel, And then in there, you just give a string, which will be the name of that you want to give. So let's just stick to saying X axis. I know it's not very extravagant, but bear with me. This is a basic example. Then, as you might have guessed, if you want to do it for the ordinate axis, then you do plt y label, and then we'll just change it to X axis. And actually, if we want to give a title to the plot, we do plt title, and then same thing, we give a string with the name. So example graph, let's call that like this, or example plot maybe. Anyways, let's run this, and we'll see that now we indeed have something that is a bit more meaningful, where we have labeled things correctly now. Let's now have a look at a different type of plot. So maybe this is sort of a line plot if you want, but maybe you want to visualize this data with something, for example, like a bar plot. So let me actually put back these points here, use them again. And here we'll do a plt bar. So as I said, very intuitive. And then we'll put X comma Y, and we need to say plt show for the code to actually display the plot. Okay, if we run that, you can see that now we have a bar representation of this plot. Forgive me for this example, I'm not going to put the labels anyway. So this is a bar representation of this set. So you can see that at the first X, we have the bar at 1, and its elevation, its height, if you want, is going to be given by this number that we give in the Y list. So this is a 2. So that's why we're here. The second point is 2. And then this one should be at an elevation of 20. And that's indeed what we have. For example, if we could have had 200, and you'll see that if I run this, then indeed our first bar is now very big, which makes the other ones look tiny in comparison. Great. So that's the bar plot. There's another plot I want to show you. And say, for example, you wanted to do this kind of plot, but you don't want each points to be joined by a line. You just want to see the points that you've put in your list here in the X and Y. So for this, you use the plot called a scatter plot. So we'll do plt.scatter, and then we'll go X and Y. And as you know now, we'll do plt show. So let me just run this, and you can see that we have this same kind of plot here, or except that we've changed the values when we did this. So let me maybe put the values from the first plot so we can compare. Oopsie, wrong shortcut. So let me just push enter, do this, then I'll run this. And you can see that this really matches this, right? So you see, this is just the points. If we wanted to go back to our linear curve from the beginning to see that the points really align nicely, let's go back to this 10, 20, 30, 40, and 50. And indeed, you can see that now they align nicely here. And of course, if you want to add the legends and all of that, it works exactly the same, right? You just do after add this here, and you'll see that it'll come on the plot. And the same here, you can also do that. There's no problem. All these commands are universal to all the type of plots in Matplotlib.
The great thing about Matplotlib is that it gives you a lot of room for customization, whether you want to change colors, sizes, fonts, etc. But my goal is not to go over that today. For that, you can refer to the Matplotlib documentation. It's really comprehensive. Or also, I simply encourage you to check online and even ask some AI tools like ChatGPT for help. So far was also a quick introduction to show you some basics with some data that we entered by hand. Now let's shift gears and work with a real dataset from a file, and we'll be using Pandas to handle it.
So let's fetch the data. You can access it on our website. The links are below. So let's scroll down, and then you have a link here. So you open it. This will go to our GitHub. And actually the file is too big, so we can't see it here. We can just click on raw and we'll see it better. So this is a CSV file. Remember what we discussed in the previous chapter. So this is a file of some sales of houses that happened in the King County in the USA. So you see that this is a big file with a lot of information. So you have an ID, a date for the sales, the price, the number of bedrooms, bathroom, a lot of information, whether you have a nice view, for example, or gradation, whether you have a nice view, you can see some water, etc., etc. Actually, if you want a more detailed explanation of what each column mean. You have it here on our website. So anyways, so back to the GitHub, then you can download it, clicking it here, and then put it in the same folder as where you have the chapter 6 IPyWNB file or whatever you've called it. And I've done that, and now you can see that it does appear here. Okay, so let's import this file, and we'll use the same commands as we did in the last chapter. So let me simply paste them directly. So you see I imported pandas first, and then I'm using the read CSV to store all this information, all this data in this file in a data frame. So let me just add a little df here. So if I run it, it will display the data file. And there we go. So all our information is here. We can see that the data file is quite big. We have more than 21,000 rows in this data file. Great. So one of the statistics we could do is something we saw last time. So for example, let's say we want to get information about the price. Well, the first thing we could do is maybe to understand the mean of the price. So mean just like this. So if I did this, I get that the mean is this number. But okay, I mean, we have all these sales here. The mean is a first information, but maybe what would be more meaningful when we want to study the price of this data set is to understand the distribution of the price, how it looks, how many houses were sold around 1 million, around 500,000, around 6 millions, whatever. So for this, we're going to use a type of plot that is used a lot when analyzing financial data, and this is histograms. And to do that using Matplotlib, all we have to do is do plt hist, and then we will put of what? Well, the histogram we're interested in is the histogram of price, and then we need to give the number of bins. So I'll put bins equals 100. So that's basically the number of bars we want the histogram to be computed with. You'll understand that better in a minute. Okay, so then we do our plt show, and then I keep putting a 0. Then I'll just run that cell, and we can see how it looks. Okay, there's our histogram, right? And we see some bars like that. What are the few things that we see? So first, maybe we should write down what each label is. So each axis, beg your pardon. So the X label, this is simply the price. So we're going to do the price. Then what is the Y-axis? So this is a histogram, right? So it counts the amount of houses that were sold within a bar. I mean by that within the range that a bar spans over. So the Y label is a count. So let's say N houses for number of houses. So, okay, I'll run this so we'll see this better. So indeed, along the X-axis, what we have is the price. You can see that Matplotlib automatically put a scientific notation because we're dealing with big numbers. So this 1e to the 6 means 10 to the power 6, meaning a million. So you have to read this as 1 million, 2 million, etc. Now on this side, we have the number of houses. So basically, if we looked at this bar here, we would go down. At the moment, the bar's quite thin because we didn't zoom in, and we'll do that in a minute. But across that range, what it's telling us is that about 3,500 houses were sold, let's say between 0.3 million to 0.4 million, probably. Okay, now, if we take a look back at this histogram, what other information can we get? Well, if it has plotted up to here, that means we don't see it very well because of the fact that this histogram peaks high here. But at this point, that means has been some houses that were sold around $8 million. But what we see is that for the major part, most of the houses were sold in between $0 to $1 million, which makes sense, right? So maybe let's say we actually want to put a filter. So we filter out all those houses that were sold at a much higher price so we can concentrate and look at how the histograms behaves closer to those lower range where most of the houses were sold. So for that, we actually use something that we saw last time, the good old df lock. So we want to filter all the houses, let's say that were sold at a price lower than 2 million. So I'll do a lower than 2E6. And I'll close this first squared brackets. And what do we want to look at now, considering that we're looking at the location where we are doing this filter? Well, we are still wanting to look at the price. So I have to give here the price in a second square bracket. Okay, great. Let me run this. And you can see that now we have indeed zoomed in. Now we go from 0 until 2 million. Something else that happened is that we're still considering the same number of bins, but now maybe the bins are a bit too thin. So that's why we see some sort of noise around here. So I think we should reduce the number of bins a bit. Let's say we do 20. Now, indeed, we have a histogram that starts making a lot of sense and that we can analyze better. For example, we can see that between the $250,000, let's say, where would this go? Let's say, let's say roughly $350. We see exactly that there was a bit more than 4,000 houses that were sold in that price range. And we still see that above 1, for example, there is a few houses, but still most of the sales were within below the 1 million range. So you could, if you wanted to, you could now change the filter and also do that and check this here. Okay, nice. You're starting to understand that this data set is very rich and we can do some deep analysis of several things in here. And one thing I suggest we could do is to ask ourselves, what could explain this kind of distribution of the price of the houses that were sold? Well, something quite intuitive is probably the living area, right? Because the larger the house is, the more expensive it should be, for example. So why don't we try to make a plot to see if that is true and if we can highlight this effect? And for this, we should use a scatter plot. So I've just copied these few lines of code from the website, where indeed you see that I've done a scatter plot. And this time in the x-axis, I'm putting this living area. And on the y-axis, I'm putting the price. You can see that I've put a nice little title, X label, Y label, and then a show. So let's simply run it so we can see what comes out of this. And indeed, we do see a nice correlation. Obviously, it's not perfect. It's not along a straight line, but we do see that as the living area increases, the price of the houses increases. But yes, indeed, obviously, depending on the condition of the house, if it needs a lot of work or how good the view is, well, the price of that house is going to differ. So that's why we do have a spread and not a perfect line. Okay, anyway, something that I see is that maybe those points are a bit too large. So let me take this opportunity to show you how we can reduce the size. So I'm just going to add this keyword s = 5. So this is for the size of the dots. So you can see that now they're much smaller and we see things a bit better. Something else we could do is to give it a color to make it a bit nicer to the eye. And for this, I'll just come and paste this command so you can see directly. And by writing this, what I'm asking for is for the color to represent the evolution of the living area. So we're not adding actually new information with this color. We're just saying, make the color follow the evolution of the living area. And the kind of color palette grade that I'm asking for is called Inferno. So let me run it and you'll see that. So this Inferno means it's a color palette, a color scale that goes from dark purple to, well, almost black, I would say, until a bright yellow. So there we go. We've added some color. So we didn't really add any information because we just said that the color should follow the evolution of the living area. So from here until here, it just means that the point, as they go further towards this side, they go further towards the yellow. And if they go further towards this side, they go further towards the dark purple and the black. Okay, but now this color that we see here is not really giving us extra information, right? Because we're using the color to show the surface area. But we should really use this opportunity to have the color tell us something extra about this data set. So why don't we use the color to show us the number of rooms in our plot here? So here I should change, therefore, this to bedrooms. And then let's simply run it. And we get something that is actually not so much telling because all that we see here seems to have a dark color. So meaning that it is at the bottom of the color scale. And that's probably because we have some houses that have a huge number of bedrooms, so it crunches all the houses at the bottom of the color scale. So for that, let's do a little filter, and let's say that we want to only look at the houses that have 6 bedrooms. So I'll create a new data frame. df6 is equal to df of location, where in there I'm only using df of bedrooms, which are smaller than 7, strictly smaller than 7, so up to 6. And now if I want to actually plot the new data frame, I should put df6 here everywhere. Great. Let me run this. And now indeed we see something that makes much more sense. We see that we have a correlation indeed. As the living area increases, the houses tend to have more bedrooms, which makes sense. But something else that we see is that that is not true for all of them. We have like a dark spot here, a dark spot here. And this probably tells us that, well, that means this house has very big rooms compared to having many rooms to have the same surface area as this one on the side here, roughly. And so you see a correlation, but not a perfect correlation, which makes a lot of sense. Now you might say 2 things. Well, if we were really precise, we should add a legend that tells us how the color scale works. Absolutely true. And honestly, the plot is quite small, so let me use this opportunity to show you how we can make it larger. So for this, we do plt figure, and in figure, we need to put figure size, and we need to put equal, beg your pardon, to 2 numbers. So 15, the 15 will be the width of the plot, and then the next number will be the height. So if we run this, now the plot is much larger. To be honest, I don't exactly know what is the units of these numbers, but you can just do some testing, right? So if you put a 10 here, we will actually see that the plot is a bit more crunched up. So 15.8 seemed quite nice. Then I said we should probably, to be precise and complete, we should add a legend of the color. So for this, the first thing we need to do is actually store the plot into a variable. So let me just call it scatter. And then let me do it after here. We have to define a new variable, which is cbar. So generally short for color bar. We tend to use it like this. And here we have to call a method of Matplotlib, which is called color bar. And then we'll put color bar of what? Well, of our variable plot. So scatter. And then let's also say that we want to set a name, a label to this. So we'll do set label. And here we will just write n bedrooms, for short for number of bedrooms. Let me put a capital N maybe. And there we go. And then we have our PLT show. Great. So let me simply run it. And I did a mistake. I did indeed forget the R here. Okay, let's run it again. And there we go. We have a nice color bar legend that came here that is telling us that the darkest means houses with close to 0 bedrooms and the lightest goes up to 6, which makes sense, right? That's why we were seeing darker here up to here. And as we go to larger living area, but also larger price, we tend to have a higher number, a larger number of bedrooms, with the exceptions at some points here, which makes a total sense, right? Let's just plot our full data set here so we can highlight what I was saying at the beginning, where what you'll see is that indeed, actually, if you do that, we can see that some houses can have up to more than 30 bedrooms. We actually don't see them displayed here. They're probably hidden somewhere behind the dark dots or whatever. But that's why what I was saying. So it has pushed most of the houses to be that are in that region is pushed towards being dark colors. But anyway, so let's put our 6 Mac here and let's run it again. So really what you have shown here is quite an intricate plot with a lot of information where we use this opportunity of the scatter plot to highlight the correlation between the price, the living area, and the number of bedrooms. And of course, you could have done that with other characteristics in this data set.
So far, we've been plotting quantities directly from our data frame. But now we should extend our analysis and do a bit of post-processing to create new data so we can unlock some even deeper insights from our dataset.
Now, let's say we want to compute the average price of houses depending on their view. So I can use this opportunity to show you a very important method of Pandas data frames to regroup things the way you want them. So let's say df view is going to be our df, and that method I was mentioning is group by. So I forgot the B. Group by kind of makes sense, right? So what are we wanting to group our houses by? We said we were interested to see the view. And so what did we say we wanted to make the mean of? So that was the price. And then I have to ask for the mean. So what we're doing here is say group by. So regroup, if you want, in the DF all the houses depending on their view. The view, it's you see here, we see only zeros, but basically there's 5 numbers between 0 until 4, where 0 is the worst view and 4 is the best view possible. So here's what we're doing. So we're saying, yes, df group by view. Then after doing this group by, what we're interested in is looking at the price. So we're asking to keep the column price. And then on that, we're asking it to do a mean. So let's print that. So you see already what comes out of it. And what I should have really written is df view. So let me run this actually. And there we go. So this, if you remember, is not exactly a data frame, it's a series, if you remember from the previous chapter. But anyway, so what do we see is as the index, this is the view. So the view graduation. And what we can see here is the average price. So for a view of 0, so quite a bad view, the average price of houses is $500,000. Then when you get to a bit of a better view, characterized with this 1, then you see it's a little less of 1 million, 8 million. And actually 2 is roughly the same number. 3, we already get very close to 1 million, and then 4 is much more than 1 million. So actually, let's use that opportunity to do a bar plot so we can visualize this better. So let's do plt bar. And what are we going to put here? Well, we should do df view. And what we're going to put as our x-axis, well, that should be the index because we want to put the view as the x-axis. And now, because this is a series, what this column is the column value. So you have the index column and the value column. So then we do df view dot values. Let's then do a little plt show, and then we should see our bar plot. Actually, you know what? Let me take this opportunity to simply change the color so I can show you how we could do that. So let's do a little purple. Okay. So you see I'm just adding very simply an extra keyword and giving color equal a different color, and the color you give it as a string. Okay, so there we go. So what do we see here? Well, it's quite interesting to see that actually in terms of average, whether the view is 1 or 2, the average is very similar. And funny enough, the view 2, it is a better view than 1. Well, we see that the average value is slightly lower than the one with 1. We see that with the 0 is much lower than these 2. 3 is slightly more, but then clearly this starts having a big gap where the view 4 is now very high. And remember, this is 1 million. So as we said when we did the computation, it's a bit more than $1.4 million. Now I'd like to show you how to make a time-based plot. So remember that we do have a column where we have the date of when the sales of each houses was made. So that is a string that is stored in here. So I remember what we did in the previous chapter on how to convert this. So let me actually paste what I had written on our website. So you can see that the way to do this is using this pandas to date time method. So we're doing that first to convert these dates into something meaningful. And then here we're grouping in months. So I don't want to go into details about how this method works. We're going to look into it much more in a future chapter where we're going to see quite in detail how to deal with dates and times and things like that. But what you have to understand is that our plot is not going to be as a function of the date exactly. We're going to summarize everything in terms of months. So regroup in terms of month, I should say, better. So you can see, so it's a bit like our group by if we want. So we're saying now resample the data set, and for each month you do the mean. And there we go. So we have our DF regrouped. So let me actually show you what it looks like before we get to do the plot. So this, as you can see, we now have each line is a month. So basically all these values that we have here correspond to the mean of all the values that were included before in this given month. Okay, so actually, let me show you if we do price, because what we want to see is the evolution of the price average on each month. So if I do this DF group price, you can see that we also have a series here. So actually now let me uncomment this, and I want to show you a little trick. You don't actually have to give both the X and the Y. If you do this, Matplotlib understands completely what this should be plotted. So if I run this, as you can see, we have our average price here and the date, which is each month. And we can see, for instance, that the price was quite high at the beginning and high at the end, but we had a quite major decrease in the middle of the period over which the dataset spans. You might start to understand that the possibilities with plotting are practically endless, and Matplotlib is really so flexible and functional that you can do whatever you basically can imagine. So here I've put a link to the Matplotlib website where you have its huge bank of possible charts. There's so many. I mean, you wouldn't believe I'm scrolling down and I'm only halfway. But for example, here you can see some pie charts we haven't looked into, but that can be quite interesting, especially in the financial sector. Something we haven't seen, but that you might need, for example, is 3D graphs, 3D plotting. So you can see some nice ways of plotting some 3D plots here. And the cool thing, you can all access the code. So you just click and this will give you the code and you can copy it and change it to your need. So that's really powerful. Now, one thing about Matplotlib is that it can get quite technical, and when you're not used to it, it can seem maybe a bit less user-friendly. So there was another library I wanted to bring your attention to, which is called Seaborn, which is also used quite a lot. So this is based on Matplotlib. So it's just an extra layer above Matplotlib that makes it, in general, a bit more user-friendly. So slightly less customizable in a certain sense, but a bit more user-friendly. And in general, also plots that you will do with that kind of naturally look a bit better. Although, as I said, it's an extra layer above Matplotlib. So you could do all of this directly in Matplotlib. But you know what? Just pick what suits you best. And I mean, you can see there's a lot of fancy things that you can do. But I do want to say that sometimes it's quite easy to fall into the trap of going too crazy in your plots, putting loads of fancy things, etc. But you know, in the end, sometimes the simpler, the better, because you want to convey a very specific information. So sometimes doing too much is just going to blur the message you're trying to convey. So just be mindful of that, but do try things out and experiment.
Okay, I think we've covered enough. It's time for this chapter's practical exercise.
There's honestly a lot that could be done with this data set. So the best way for you to train would be for you actually to invent your own questions and do your own plots. So you train in data analysis and visualization. But if you don't have too much inspiration, no problem. We suggest 5 questions in this exercise. So the first will be to display the 5 largest sales volumes by year. The second one, we ask you to do a price distribution for houses with versus without a water view. Then, quite interesting, we ask you to do a correlation diagram. So we'll look into these in more detail in the next chapter, but I think it's a good idea for you to practice before. And actually here, Seaborn has a very nice code to do some heat maps that you can find here. So here's the code. So you can use that. In the second question, we ask you to do a box plot of price by grade. And finally, we're asking you to do a scatter plot of the price versus the living area with a linear regression. So that can be interesting as well. And if you need, here's the link to the correction.
Great, we're done for today. I hope you got some value out of this. If you have, don't forget the good old likes, subscriptions, notification bells, share this course with people who might enjoy it, or even join our community Discord if you feel like it. See you in the next chapter, and take care.